In the previous session of division of polynomials, we have studied the synthetic division method. Let us learn the next concept about the division of polynomials, that is remainder theorem. So this is the theorem by which if we divide a polynomial by another polynomial, by this theorem we can find the remainder. So we can define it as if the polynomial p of x is divided by x plus a, then the remainder is same as the value of the polynomial p of x for x is equal to minus a. That is, if we divide p of x by x plus a, the remainder will be same as p of a. So this is known as a remainder theorem. Now to illustrate this, we'll solve some examples. First example is divide the polynomial x cube plus 3x square minus 4x plus 2 by x plus 2 and find the remainder. So mind that remainder theorem is only useful for finding the remainder when we divide a polynomial by the other polynomial. So first let us name the given polynomial, that is, let p of x is equal to x cube plus 3x square minus 4x plus 2. We have to divide this polynomial by x plus 2. So we have to find the value of this polynomial for x is equal to minus 2. And this is because for this we have to divide the given polynomial by x plus 2. So we should equate that to 0. So if we transfer plus 2 to the right hand side, it will become minus 2. So now we have to find the value of given polynomial for x is equal to minus 2. So for x is equal to minus 2, the polynomial p of x will become p of minus 2 is equal to, now we have to replace the variable x by minus 2. So firstly we have the term x cube, that should be minus 2 cube plus 3 into x square, that's why it is 3 into minus 2 bracket square minus 4 into x, that is 4 into minus 2 plus constant term 2. Now we have to simplify this one. Minus 2 cube is minus 8 plus 3 into minus 2 square. Now we know the square of negative term is positive, so minus 2 square is 4. Now there is a product of two negative numbers, so that should be positive. 4 into 2, that's 8 plus 2. Now here minus 8 plus 8 will get cancelled. 3 for the 12 plus 2, that is equal to 14. So here we get the value of polynomial for x is equal to minus 2, that is p of minus 2 is equal to 14. So that is why the remainder is 14. That is, if we divide the polynomial x cube plus 3x square minus 4x plus 2 by x plus 2, we get the remainder 14. So this is how, by using the remainder theorem, we can find the remainder if we divide a polynomial by the other polynomial. Let us solve another problem based on the remainder theorem. The question is, if the polynomial y cube minus 5y square plus 7y plus m is divided by the polynomial y plus 2 and remainder is 50, then find the value of m. So in this question we have to find the value of m. So firstly we have to name the polynomial which is to be divided. So it is given that in that polynomial the variable is y, that's why we name that polynomial as p of y, that is equal to y cube minus 5y square plus 7y plus m. Now if we divide this polynomial by y plus 2, the remainder is 50, that's given. So if we have to divide by y plus 2, we will equate it with 0 so as to get the value of y as minus 2, because 2 transferring to the RHS, we'll get minus 2. Now here we have to use the remainder theorem. That is, if we divide the given polynomial, that is p of y, by y plus 2, we will get the remainder which is same as p of minus 2. So by remainder theorem, if we divide the given polynomial by y plus 2, we will get remainder which is same as p of minus 2, because we have to divide the polynomial p of y by y plus 2. So now we have to solve this one. Remainder is given over here, that's 50. So substitute remainder here is equal to, now to find the value of p of minus 2, we have to substitute the variable y by minus 2 in the given polynomial. That is, first term is y cube, so it should be minus 2 cube minus 5 into y square, that is 5 into minus 2 square, plus 7 into y, that's 7 into minus 2, plus m. So 50 is equal to minus 2 cube is minus 8 minus 5 into minus 2 square is 4. Now there are two numbers which have different signs, we have to multiply them, so plus minus, the product will be minus 7 into 2, that's 14, plus m. Now if we solve this equation, we will get the value of m, that is 50 is equal to minus 8 minus 5 into 4, that's 20, minus 14 plus m. So that's 50 is equal to minus 8 minus 20 and minus 14. We have to add all of these. So minus 8 minus 20 you will get minus 28, minus 14 we will get minus 42, plus m. Now we have to find the value of m. So transfer minus 42 to the left hand side, so as to get 50 plus 42 is equal to m, that is 50 plus 42 is 92, that's m. So here the value of m is 92. So to find the value of m, we have used here the remainder theorem. The next concept is factor theorem. Suppose there is a polynomial p of x given, and if a is any real number, and if we find the value of that polynomial for a, and if p of a is equal to 0, then we say that x minus a is a factor of p of x. Or conversely, if it is given that x minus a is a factor of the polynomial p of x, then from that we can write p of a is equal to 0. Now to illustrate this, let us have an example. Suppose if there is x minus 1, which is a factor of polynomial p of x, is equal to x square minus 1, then we say that p of 1 is equal to 0. Now let us solve one example based on this theorem. The question is, use factor theorem to determine whether x plus 3 is a factor of x square plus 2x minus 3 or not. So for this one, first we have to name the polynomial which is given, that is, let p of x is equal to x square plus 2x minus 3. Now we have to decide whether x plus 3 is a factor of x square plus 2x minus 3 or not. So for that, first of all, we have to equate x plus 3 to 0 so as to have the value of x, that is, the value of x then will be minus 3, that is, x is equal to minus 3. Now for x is equal to minus 3, we have to find the value of the polynomial p of x, that is, for x is equal to minus 3, we have p of minus 3 is equal to, now to find the value of p of minus 3, we have to replace the variable x by minus 3, that is, x square instead of x square we should take minus 3 square plus 2 into x, that is 2 into minus 3 minus 3. So minus 3 square is 9. Two positive negative terms are there. One positive, one negative term is there. So product will be negative. 2 into 3, 6 minus 3. That is equal to 9. Minus 6 minus 3 will be minus 9, which is equal to 0. So as here p of minus 3 is equal to 0, according to the factor theorem, if p of minus 3 is equal to 0, then x plus 3 is a factor of the given polynomial. And suppose if p of minus 3 would not be equal to 0, at that time it would not be a factor of x square plus 2x minus 3. But now in this case we have got here p of minus 3 is equal to 0. That means x plus 3 is a factor of x square plus 2x minus 3. Therefore we can write here, by factor theorem, x plus 3 is a factor of x square plus 2x minus 3. Let us solve another problem based on the same theorem. The question is, if x minus 2 is a factor of x cube minus mx square plus 10x minus 20, then find the value of m. Now in this question, the factor, it is given that x minus 2 is a factor, and from that we have to find the value of m. So again let us name the polynomial, that is p of x is equal to x cube minus mx square plus 10x minus 20. Now it is given that x minus 2 is a factor of this polynomial. So we will equate x minus 2 with 0 so as to have x is equal to 2. Now as x minus 2 is a factor of the given polynomial x cube minus mx square plus 10x minus 20, if we find the value of p of 2, it will be 0, as x minus 2 is a factor of the given polynomial. Therefore by factor theorem we will have p of 2 is equal to 0. Now to find the value of p of 2, we have to replace the variable x in the given polynomial by 2. That is, x cube means it should be 2 cube minus m into x square, it is m into 2 square, plus 10 into x, that is 10 into 2, minus 20 is equal to the right hand side as it is. So if we simplify this one, 2 cube is 8 minus m into 2 square 4 plus 10 to the 20 minus 20 is equal to 0. Here plus 20 minus 20 will get cancelled. So we have 8 minus m into 4, that's 4m is equal to 0. Now we have to find the value of m. So we'll transfer minus 4m to the right hand side. So we'll get 8 is equal to 4m. That is, if we have to find the value of m, we should take 4, the coefficient of m, to the left hand side. So it will become 8 divided by 4 is equal to m. So if we divide, we will get 2 divided by 1, that is 2 is equal to m. That means m is equal to 2. So this is the value of m. We will solve the next problem. The question is, show that m minus 1 is a factor of m raised to 21 minus 1 and m raised to 22 minus 1. So to check whether m minus 1 is a factor of these two polynomials, we have to use here the factor theorem. So first of all, we'll name these two polynomials. So let p of m is equal to m raised to 21 minus 1 and let q of m is equal to m raised to 22 minus 1. So firstly we have to check whether m minus 1 is a factor of p of m. So if it is to be a factor of p of m, so we have the polynomial m minus 1, which is to be decided whether it is a factor of these two polynomials p of m and q of m or not. So we should equate it to 0 so as to get the value of m as 1. So if we find the value of p of 1 and if it comes 0, then at that time we can say that m minus 1 is a factor of p of m. So let's have the value, that is for m is equal to 1, we have p of 1 that is equal to value of the polynomial p of m is equal to m raised to 21, that is we should have now 1 raised to 21 minus 1, that is equal to, now 1 raised to 21, that means any power of 1 is a 1. That's why 1 raised to 21 is 1 minus 1, that is equal to 0. So as p of 1 is equal to 0, so by factor theorem we can conclude that m minus 1 is a factor of m raised to 21 minus 1. Similarly, for m is equal to 1, if the value of polynomial q of 1, if it comes 0, then we can conclude by factor theorem that m minus 1 is also the factor of m raised to 22 minus 1. So let's check that one. We'll find q of 1 that is equal to m raised to 22, that means 1 raised to 22 minus 1, that is equal to, again any power of 1 is 1, that is 1 raised to any number we will get 1 again. So 1 raised to 22 is 1 minus 1, that is equal to 0. So q of 1 is also 0, that means again by factor theorem m minus 1 is a factor of m raised to 22 minus 1. If you like the content, please subscribe the channel. Thanks for